Now we're looking at some evaluation versions of these. There's a little bit of kind of our own thoughts that we have to put into thinking about how we're going to do this. So if we have cosine of 75, basically what we're really kind of breaking this down into is we need to think of it in some form of either 30s, 45s, or 60s. Some kind of combination of adding those together to get to this value. And so I think what we can do is say that this is cosine of 30 plus 45. And then from that, we could crunch the numbers and see what that would be. So first step is to actually just go write out our formula. So this is cosine, so we're going to use the cosine version of it. I mean, we're repeating this formula so many times that maybe you'll just memorize it from exposure. Cosine formula is the opposite. And at this point, we just need to go through and evaluate these values on the unit circle. So, I mean, all you really need to kind of consider is here at 30 degrees, we're looking at a value of square root of 3 over 2, comma 1 over 2. And then at 45, we're looking at values of square root of 2 over 2 and square root of 2 over 2. So as we just go through and compute this, cosine of 30 is the x value. So cosine is going to be square root of 3 over 2. Cosine of 45, square root of 2 over 2, minus sine, which is the y value, times sine y value there. And so all we do is just multiply these together. And we would get, on this first piece, square root of 6 over 4 minus square root of 2 over 4. So we can combine that and say square root of 6 minus square root of 2 over 4. Yeah, can't simplify that any further. All right, so I'll double check that real fast. Forehand. All right, so this one, I don't know. So my initial thought on that is to break it up into, or like turn it into a coterminal angle. So I would be thinking about this question instead of 375. You know, you can get your coterminal angle just by doing that angle. So 375 minus 360 will tell me that that's 15. So really we could do the same problem as cosine of 15 degrees. And then we just got to think about how could we get 15 out of our combinations of 30, 45, and 60. I would think there's actually two different ways we could do this. We could do either, and I need my little drawing glove. We could do cosine of 45 minus 30, because that would be 15. Or we could do cosine of 60 minus 45. And they would actually, if we worked them out, we would get the same answer either way. But since I already wrote down the numbers, I'm going to do 45 and 30. And so we apply the cosine formula and see where that takes us. So this would be cosine of 45, cosine of 30. The cosine formula uses the opposite sign of what was there. Sine of 45, sine of 30. And we have all those numbers from before. So cosine of 45 is square root of 2 over 2. Cosine of 30, square root of 3 over 2, plus square root of 2 over 2 times 1/2. Which actually seems very reminiscent of how this one played out. But yeah, I've got the same values. And we just multiply it all together. This is going to end up giving us square root of 6 over 4 plus square root of 2 over 4. And so that's going to just combine into square root of 6 plus 2, square root of 2 over 4. And that would be our answer for that one. So this one, again, kind of the same problem. I really want to convert it into a coterminal angle. And so I'm just going to take that value of 165 and add 360 to it. And that's going to give me, was it 195? Sometimes I don't always trust my math. Oh. Yes. Okay. And now it's back to that same issue of we just need to figure out angles or things that would sum up to this. So since it is a ends in 5, I'm really going to be thinking that it's probably going to be some variation of 45 plus a thing. And if we take out 45 from that, we're ending up with 150, which is a unit circle value that we can compute. So if we think about that, that's going to be right there. So this is -1, 0. So this unit circle value is going to be -3, square root of 3 over 2, 1. And then our other unit circle values over here at 40, which is going to be square root of 2 over 2, square root of 2 over 2. And then we just apply the sine rule here for splitting this up. Sine is going to be the same sign. So it'll be sine of 45, cosine of 150, plus cosine of 45, sine of 150. And then we just go through and plug in what we know from our unit circle here. Sine of 45 is going to be that value right there. So square root of 2 over 2. Cosine of 150 is this value. So negative square root of 3 over 2 plus the cosine of 45 and the sine of 150. Multiply all this together. We end up with negative square root of 6 over 4 plus square root of 2 over 4. So we add that together and we get, however you want to write it, negative 6 plus 2 over 4. Square roots of. So sine of 105. Again, it's got that that 5, so that's going to make me think. Break it into a 45 plus 60, and that should be pretty quick. In case we need to remember our unit circle values at 60, that is the final step before we get back to 90. So that is 1/2 comma square root of 3. And we know our 45 from up there. And if we're doing sine, it's going to break down into the same version of that formula up there. So it'd be sine of 45 cosine of 60 plus sine of 45. Oops. That's cosine of 45 and sine of 60. And so we know these values. This is square root of 2 over 2. Cosine of 60 is the x value, so that is 1/2, plus cosine of 45, square root of 2 over 2. Sine value is the y value, so 3 over 2, square root of 3 over 2. Multiply all that together, end up really getting kind of the same type of stuff. So square root of 2 plus square root of 6 over 4. No negative signs, even though my handwriting looks kind of bad there. Jumping over to this next set is really just a matter of doing it backwards. So looking at this, I see that it was broken down using the sine formula. And knowing the sine formula, it's going to, because this is the positive, it's going to be the same sign. So we know this is going to turn into sine of 95 plus 55. And so that'll turn into sine of 150, which is a pretty easy unit circle value. That's the one right here. This is negative square, oh wait, that's the cosine, but negative square root of 3 over 2 and 1/2. So this will just end up being 1/2. Looking at this next one, this looks like the cosine formula. And remember, the cosine formula uses the opposite sign of what was there. So this was originally cosine of 160 minus 40, which is going to turn into cosine of 120. And that is going to be this value right here on the unit circle, which is the x value that we want, and that is negative 1/2 comma square root 3 over 2. And so that is going to be negative 1/2. Now, tangent, a couple of things we could do here. We could use the tangent rule. So we could use this and see where it takes us. Or we could just write it as sine over cosine and do that. So let me see. Looking at this, this is kind of wanting us to split it. And I guess we could try the tangent formula. So let's see what that takes us. So if we have tangent of alpha plus or minus beta, that is supposed to be tangent of alpha plus or minus, so matching sign, tangent of beta over 1 minus or plus, so the opposite sign here, tangent of alpha times the tangent of beta. So to do this, we're going to have to figure out a bunch of tangent values. So we need to know what tangent of 135 degrees is. Does my little cheat sheet have a unit circle? Yes, it does. So we're dealing with tangent of 135. So tangent is, oh, that's going to probably be -1. And then we need tangent of 120. And if I look at my unit circle, tangent is y over x. So that would be square root of 3 over -1. So that's just negative square root of 3. If I really want to double check, punch it into here. So we could do tangent where's the degree button on this thing? There it is. Oh. Yeah. It was already in degrees. So, yeah. So we know our tangent values. This one in red is my alpha. This one in blue is my beta. And we just go through and plug it all in. So we know on this top here we have -1 plus, because it's going to mimic the same sign, negative square root of 3 over 1 minus tangent of A, which was -1, times tangent of B. So a little bit of working things out here. Top really isn't going to do a whole lot. Down here, this becomes positive. So I wonder if this looks like this is going to probably simplify a little bit. Well, interestingly not, it does not simplify a little bit. Alternatively, you could have not factored out this 1 and left it as -1 plus negative square root of 3. Would have been about the same thing. And then on number 8, we have to pick the splitting up of the tangent ourselves. So, like I said, I'm pretty lazy, and I'm going to pick 45 almost every time. So I'm going to pick 45 plus 300. So that just means I need to figure out those tangent values. So the alpha, which is tangent of 45, pretty easy. That's just going to be 1. And then beta is tangent of 300. And I'm going to look at my unit circle for that. 300, remember, it is y over x. So that would be negative square root of 3 over 1. So just negative square root of 3. And we just need to plug it all back into this tangent formula. I'll scroll up so that I can see it. So it goes tangent of A first. So that would be 1. And I chose to use plus. Plus tangent of B. Just negative square root of 3. Over 1 minus tangent of A times tangent of B. So that works out a little bit. Not a whole lot we can do to clean this up. 1 minus square root of 3 over 1 plus square root of 3. Now, could you simplify this and rationalize it? Probably. Do I really want to rationalize it? Not really. But if we did want to look at rationalizing, typically to cancel out the thing on the bottom, you would multiply the top and the bottom by the conjugate. Now, I don't know if they would have covered this, but when you have the conjugate here, it's going to FOIL out to some pretty nice stuff. I think I need to go to a new page here to work through this. Or my thing does not like. I forgot how to increase the page size here. Well, we'll just jump over to MS Paint. So we were doing and then we're multiplying by the conjugate, which is basically the same thing on the bottom, just with a different sign. And this is mathematically legal because this is just multiplying by 1 because it's the same thing over the same thing. So it basically FOILs out. And I think it FOILs to this. 1 minus the square root of 9. On the top, we end up getting 1 plus the square root of 9. 9 is a square rootable value, so this is going to then turn into 1 plus 3 over 1 minus 3, which is going to give us 4 over negative 2, which then just gives us negative 2. So that final answer would have rationalized down to, of course now it lets me draw on that, negative 2. And so we probably could have rationalized the previous one, and we can very easily double check that. This was tangent of 345. So if we punch that into our thing here, interesting. Did not get that. So that does kind of make me curious if I rationalized it right. So let's just compare our values here. I can't even find the square root button. So this value here was correct. Perhaps I didn't FOIL things correctly, which is also very possible. Oh. Yeah, that makes sense. I didn't FOIL things correctly. Yeah, the top here is wrong. That's not what that would FOIL to. The bottom's right, but the top certainly is not. The top wouldn't cancel out magically like that. We would actually still be stuck with 1 minus 2 square root of 3 plus square root of 9. And so that still turns into 3. So we get 4 minus square root 2 square root 3 over negative 2. And put the negative out in front. So 2 minus square root of 3 should be what that rationalizes to. And we will double check that. Yeah. So I just rationalized it wrong. So the correct rationalization value would be negative 2 minus the square root of 3. All right. And the last set here is really still doing much the same that we've seen in a lot of the previous. I mean, there's some extra weirdness with like cotangent there. But, you know, so this is using the sine formula. So it should be sine of 270 cosine x makes the same sign right here. Cosine 270 sine of x. So 270 is on the bottom of the unit circle, which is 0, negative 1. So the cosine is going to cancel out. So this cosine of 270 evaluates to 0. That cancels. This evaluates to -1. -1 times cosine of x. What gives us our negative cosine of x. This tangent one, I would want to solve where I turn it into sine on top, cosine on bottom, because I think that's going to lead us to cotangent better. So when we do this, the sine on top will be sine of 90, cosine of x, same sign, cosine of 90, sine of x over. Cosine is cosine cosine, so it does cosine of 90, cosine of x with a different sign, sine 90, sine x. So 90, if we're thinking about our unit circle, is at the top, which is 0, 1. So that means cosines will go to 0, sines will go to 1. So this goes to 1. This cosine goes to 0, which will just completely knock out that term. This cosine 90 goes to 0, knocks out that term. This sine of 90 goes to 1. So when we clean this up a little bit, we've got cosine of x over negative sine of x, and that is where we're getting our cotangent. This one is just breaking it up on the other side, and that's going to be kind of the case with number 7 as well. So it's radians now. So whoop, I really need my glove. So cosine is cosine pi, cosine x, opposite sign. And we just evaluate that. If we recall, sine is over here, which is -1, 0. So sine values of pi will go to 0, which then knocks out this term. Cosine turns into -1. And we get negative cosine of x. And then we do the same thing for this next one. It'll be cosine of pi over 2, cosine of x, opposite sign, sine of pi over 2, sine of x, and we just need to evaluate what pi over 2 is. Pi over 2 is up here, 0, 1. So cosines go to 0, sines go to 1. So cosine goes to 0. Sines will go to 1. And we can see we got our -1 sine x. And that wraps them up. You can see it's really just that same formula over and over and over and over again. Honestly, I would avoid the tangent one. Sometimes it is helpful. But it's really just a matter of applying the formula, evaluating what you know, or in some of the previous problems that we saw, figuring out what we don't know and using our knowledge of trigonometry to kind of fill in those pieces. But that covers it. Hopefully you can find the answers to the ones that you were stuck on. and shoot me a text if you have any more questions.